Hello, my name is Suraj. Welcome to this video on quantum tunneling and transistors, where we will understand why computers cannot physically get very small. Imagine a ball rolling on a surface with a hill. If the ball has enough energy, it can roll over the hill and continue on to the other side. However, without enough energy, the ball will stop and start rolling back. Thus, according to classical physics, it is impossible for the ball to be at the other side of the hill without going over it. However, things are different in quantum physics. Electrons are like spinning spheres, but they're not just solid spheres. They also exhibit wave-like properties, spreading out and interfering with themselves. The hill in our analogy is a quantum barrier that impedes the ball's waveform, but it does not completely nullify the wave. When the ball encounters the hill, there's a small non-zero chance its wave penetrates the hill and the ball appears on the other side without going over the hill. This is called quantum tunneling, a phenomenon in which electrons pass through barriers that they should not be able to, according to classical physics. Quantum tunneling is important for computer design. Computers are made up of tiny switches called transistors, which control electric flow. The most important part of a transistor is its gate, which blocks or allows current to flow in it, acting as a quantum barrier. The size of transistors affects their performance and power consumption. Smaller transistors can switch faster, use less energy, and fit more on a chip. However, there's a limit to how small they can get before quantum tunneling becomes a problem. At atomic levels, a transistor's dimensions could be comparable to the wavelength of electrons. This means that electrons can tunnel through the barrier created by the gate voltage and leak even when they're supposed to be blocked. This reduces the reliability and efficiency of transistors, also generating unwanted heat. So, engineers have been working on improving transistors in other ways, for example, by creating innovative carbon nanotube transistors. Thank you.